Okay, so this video is going to talk about how to solve half-life problems. And there's sort of a general process that I really recommend. There's more than one way to solve them, but I have a strategy that I find works really well for students that I'm going to recommend you use. Okay, so anytime we do a half-life problem, it really is important that we think about the concept. What does half-life mean? So half-life is the amount of time it takes for half of a radioisotope to decay. So if I had 100 grams of a certain radioisotope, after one half-life, I would have 50 grams of my original radioisotope remaining. The rest would have decayed into daughter nuclei. Okay, so when we solve these problems, there's really four things that come into play with these. We have the starting amount. So that's however much of the radioisotope I had to begin with. The final amount. The half-life, and the total time elapsed. Now, whenever you're given a problem, you're going to either be given or easily be able to find three of these, and you'll be solving for the fourth. Okay, so this problem says a certain isotope has a half-life of 15 days. If I start with a 20-gram sample, how much will remain after 60 days? Okay, so sometimes these are a little overwhelming, large word problems with lots of things, so I think it's helpful to underline all of the things that are given. Okay, now half-life and total time, these are going to be measured in time. So that would be days, hours, etc., some unit of time. These will be amounts, so grams, milligrams, etc. Okay, so a half-life of 15 days. All right, so that's pretty clear. That must be the half-life. If I start with a 20-gram sample, okay, so it's an amount, so it must be one of these. And it's specifically saying I start with that, so that must be my starting amount. Okay, how much will remain after 60 days? So that must be the total time that's elapsed. Now, before I can figure out my final amount, I really have to know how many half-lives occur during this 60-day period. Well, if each half-life is 15 days, I can say, okay, 15 days, 30, 45, 60. That's 4 half-lives. Another way to think of it is that the number of half-lives equals the total time over the half-life. So 4 half-lives go by. I usually use arrows to represent half-lives. And so we're going to draw some nice little arrow diagrams. I find these really helpful. I recommend that you do this every single time. If you avoid doing it, sometimes you may do one too few or one too many half-lives. So I think it's worth the time. Okay, so I start with my starting amount, and I know that I'm going to have 4 half-lives, which means I'm going to need 4 arrows. So after my first half-life, how much will I have? Well, it divides by 2, so I'll have 10. After my second half-life, again, we're dividing by 2 every time, I'll have 5. After my third half-life, I'll divide this by 2 again, I'll have 2.5. And after my fourth half-life, I'll have 1.25 grams. I also like to number the arrows. It just helps me keep track of how many half-lives I've used. Okay, so my final amount is 1.25 grams. Yay, problem solved. All right. Now let's look at solving for a different item here. So every time I'm going to write my 4 things, I usually abbreviate them because it's much, much, much faster. Starting amount, final amount, half-life, total time. All right, so iodine 131 has a half-life of 8 days. Okay, so that must be my half-life. How long will it take for a 50-gram sample to decay to 6.25 grams? All right, so I have 2 amounts. My larger amount must be my starting amount. Okay. So I have 50 grams decaying to 6.25 grams. And I know how long each half-life lasts. So what I need to do now is figure out how many half-lives it takes to get from 50 to 6.25. So after my first half-life, I'll have 25 grams. After my second half-life, I'll have 12.5 grams. And after my third half-life, I'll have 6.25 grams, which means that it took 3 half-lives to get from my starting amount to my final amount. Each of these represents 8 days. So 8 plus 8 plus 8 equals 24 days. Or more simply, you can multiply 3 times 8. So that's my final answer. All right. Now let's look for a problem where we're solving for the half-life. All right, so it specifically says, what is the half-life? So I know that that's my unknown here. If it takes 14 years for it to decay from 10 grams to 2.5 grams. So again, notice I'm underlining all the things that are given in the problem to help me sort of pull them out. All right, so my total time is 14 years, and I'm going from 10 to 2.5 grams. So that must be my starting amount and my final amount. Again here, since I'm missing one of the time units, I'm going to basically figure out how many half-lives it takes to get from my starting amount to my final amount. After 1, I have 5. And after 2 half-lives, I have 2.5. So it took me 2 half-lives to get from my starting amount to my final amount. Now, both of those together are 14 years. So how long was each one? Well, it must have been 7 years. Another way to think of that is to take the total time divided by the number of half-lives, and then you'll get the half-life. Okay. Finally, we can actually find the starting amount too. Now, initially this seems a little bit trickier because we're going to have to work backwards, but really it's not that much different. Okay, so this says an isotope has a half-life of 3 minutes. All right, after 9 minutes, 2 grams remain. How much of the sample was present initially? So I'm trying to find my starting amount. I know that the total time is 9 minutes and that I had 2 grams at the end. Okay, so here I know how much is left at the end. Now, I have to figure out how many half-lives occur, how many arrows I need to draw. All right, so 3 minutes is 1 half-life, then 6 minutes is 2, 9 minutes is 3. Again, the number of half-lives equals total time over half-life, which equals 9 divided by 3 is 3. All right, so I need 3 arrows. So I'm working backwards. Going back in time 1 half-life, I would have had twice as much, so 4 grams. Going back in time another half-life, I would have had 8 grams. And finally, going back in time for a third half-life, I would have had 16 grams. Okay, so when you're finding the starting amount, you're basically starting at the end and going backwards, and you have to multiply by 2. Okay, this is one of those things, again, it gets so much easier with practice, so do the homework and just email me or let me know if you want to meet with me to ask any questions. Good luck.